Hello everyone, and this is episode 20 of Case Done. My name is Pisik, or you can call me Benz as usual. And also, I plan to bring you actionable insights about AI and generative AI for you and your team to boost your productivity or come up with new features on your products. And today we have very interesting and exciting topics, and everyone should have probably heard about DeepSeek. So today we are going to talk a little bit on a lot of topics about DeepSeek, starting with the brief introduction of what it is, why it is so interesting or create a lot of buzz in the world. And then after that, we are going to dig a little bit deeper in how we will use DeepSeek with Ollama. Then naturally, we want to use it with Open WebUI. And eventually for developers, we will look into how we can use it with Visual Studio Code. And I will show you some applications that will integrate DeepSeek model into tools that LangChain has. And specifically, this is going to be revisiting our YouTube video summarizer, but we now use DeepSeek models to do the summarization. And last but not least, we'll touch a little bit upon how can you use DeepSeek with Agentic AI systems. Before we actually get started, don't forget to subscribe to my channel, Case Done. We are officially on YouTube, but also on Facebook, LinkedIn, X, Substack, and GitHub. So for the first topic, let's understand a little bit more about DeepSeek, right? But not too deeply. DeepSeek R1, it's one of the model that is really good at reasoning ability and at the level of OpenAI's O1 models. And as you can see from this performance chart here, where the box, the blue box with stripes is the DeepSeek R1 modeled, and the most dark gray box is the OpenAI O1 model. And you can see that DeepSeek R1 model has kind of like similar performance compared to the OpenAI O1, which is a model known for its reasoning ability because it has an imbued chain of thought process in the response of the model. Now, even though it has reasoning ability similar to the O1 model from OpenAI, the cost is much lower. And I've put some cost per million tokens between OpenAI and DeepSeek R1 modeled right here, and you can see that for the input, OpenAI takes about $15 per 1 million tokens, while the DeepSeek R1 will cost you only like 15 cents, and this is like 100x cheaper. On the output side, again, OpenAI O1 will cost you $60 per 1 million tokens, while the DeepSeek model is a little bit above $2, and the cost difference is 27 times. So that's why it has created a lot of buzz in the AI world that, oh wow, with the same level of reasoning ability, but you get like 100x cheaper in the input and 27x cheaper in the output. Aside from the performance and the cost, the DeepSeek team has open sourced its weight and describe how they came up with the R1 model in terms of the training, and it has some like interesting training techniques. The training techniques that the team of DeepSeek R1 took reduced the amount of the supervised fine-tuning data that is needed for the model to perform really well, and this translates to less effort in high quality human annotation data, and that makes like training models much more easily and less costly as well. Now, another technique that is being employed and helps reducing the complexity of training the LLM is they employ the GRPO, which stands for Group Relative Policy Optimization. Typically, the model like maybe like back to like GPT-4, it uses the PPO, the Proximal Policy Optimization. while the GRPO is kind of like not identical, but a little bit there's some differences in there. The main thing to take away from this picture is that with the old ways of training or fine-tuning the model in the last step, instead of having the PPO, in the PPO version, you need to train two models, the policy model and the value models, which is needed to what's the word here, compute the advantage. That's some kind of like word in reinforcement learning, but essentially you need to train this model to get the A value, which will be then used to update your model, right? And this is where the computation cost is, because you need to back propagate the errors and update these models. Now, for the GRPO, the team proposed a different way of calculating the A's without relying on the value. So in this training GRPO scheme, you only need to train the policy model. And this removes the complexity of setting up the reinforcement learning that requires two models. Now it's back to only updating one model. And because of the complexity is removed, the memory required is also removed as well, because these models are quite big, and therefore having only one of them cut the memory consumption or requirement by half. And that's about it. All the training technique and the what's the word here? The training technique and the reduction of the high quality data probably results in better training and cheaper training as well. Anyway, that's about the technical stuff. What we are actually interested in, at least in terms of users like us, is how do we use DeepSeek? And I'm not going to talk about using DeepSeek as an API call, like what you will be able to do with its website access. We are going to be focusing on how we can use DeepSeek models on your local machines. It could be your own laptop or your virtual machines, and that's where Ollama comes in, right? So again, you can download DeepSeek R1 models, well, not the full version, like maybe like you can, but probably you will not if you don't have a lot of money. You can download smaller models. Smaller models are the DeepSeek models that are created using a distillation technique, meaning once the DeepSeek team has a large DeepSeek R1 model, like the 670 billion parameters, it's going to train or fine-tune a smaller model by a way of distilling knowledge from the large model, right? And now on Ollama, you have access to six distilled models. You can go from very small model like a 1.5 billion parameters, 7 billion parameter based on the Quen model, or the 8 billion parameter based on the Llama model. So you can follow the instruction of how to download the model from Ollama. If you don't know how to do it, I have a introductory video on how to use Ollama, and it's pretty simple. Once you install Ollama in your machine, then you can pull the model to your machine and have a go with it. So let's actually do something here as well. Then let me launch my terminal. Okay, here we go. Right, if I do Ollama list, I will be able to see what models I have. Like now in my I'm using a MacBook M Pro, and it has 16 gigabyte of RAM, so I should be able to run the 14 billion parameter on my laptop, and this is what we are going to have a look at it today as well. Okay, so yeah, you will be able to do Ollama pull DeepSeek R1 and whatever version of model you want. For example, like this. If you already have the model on your laptop, it's going to be updating the models instead of pulling the model in fresh. But yeah, so that's what you need to do once in a while. When the model is updated, you need to try to like pull in the new version of the model if you wish to use the latest capabilities. Anyway, so right now I have 3 versions of the DeepSeek. Actually, yeah, 3 versions. The 1.5 billion, smallest, then the next one up, 7 billion, and the last one, 14 billion parameter. All of these models are based on the distillation technique with the Quen as a base model. All right, so this is how you set up Ollama for your machine, and when everything runs perfectly, you will be able to actually see when the Ollama load the model like this. So I think this is when I triggered the 7 billion parameter to be used, and you can actually see the number of layers and the memory that's required right here. So yeah, this is this trigger is trying to use the DeepSeek R1 model 7 billion parameter. Anyway, you are going to see this in the terminal when you run your application. Well, the next step up is, can we integrate DeepSeek and Ollama with Open WebUI? Also, this is an easy step. Once you install your Ollama and download DeepSeek model, you can serve it up with Open WebUI. So let's actually take a look at it today. Here we go. All right. First thing first, I need to make sure that my Ollama server is running, and the way to do that is simply Ollama serve. Oh, okay, it's already in use. You know what? Because of this guy is running. I don't like that, so I will quit it and hit it again. And this is where I know that everything is ready to be connected with the Ollama is now ready to be connected with Open WebUI. So let's go to the Open WebUI. So I have launched my Open WebUI already, but for those of you who is probably new to Open WebUI, what is Open WebUI? Open WebUI is a user interface tool like that allows you to have your own ChatGPT like assistant. You can type in and you can get the response back. And what is cool is that it integrates with Ollama, so you can actually serve your model locally for free, or also you can be sure that your conversation with the AI is secure. Nobody take a look at it. So that's why we probably want to try to use Open WebUI. Anyway, so if you are the admin, you would like to configure the connection with Ollama right here. So yeah, make sure that your Ollama API, your Ollama server is run, and the Ollama API is enabled here. And then when you do that, you will be able to see the list of the available models from Ollama. And in this case, we can now have a conversation with the DeepSeek. So before we actually have a chat with it, let's take a look here. So this is where when I choose to talk to the model, it will bring the model, load the model up in a VRAM, and then we can be chatting with it. So let's try to talk to, for the sake of time, actually let's try the 7 billion parameter one. So explain to me why the sky is blue. It can be as simple as question answering task, and what you see here is now it's thinking, and you can enable or expand to see what it is. So what is happening here is that DeepSeek R1, as similar to the O1, it will spend time thinking because it's forced to do chain of thought. And by chain of thought means it will slowly come up with a way to solve a particular problem. Like what you can see here, my question is as simple as explain to me why the sky is blue. Now it's kind of like explaining to itself how to solve it. For example, this is what it says. Okay, so I'm trying to figure out why the sky appears blue. I remember when I was a kid, my dad used to tell me, this is way too much. But anyway, it's just its way of working for step by step, chaining its thought to the final thought. And here it is. It has finished its thinking. And the final answer is, the sky appears blue primarily due to relay scattering. Yeah, that's if you know a little bit about physics, and this is the right answer. Okay, nothing so surprising, right? So yeah, it's as simple as download your model to Ollama, serving up Ollama using Ollama serve command, and if you are admin to the Open WebUI, come in to configure the model connection to Open to the Ollama and choose the model. It's as simple as that. All right. Next one up is what I find it's now going to be more in terms of developing stuff, but you can also benefit from integrating Ollama powered by DeepSeek with VS Code. Anyway, so this section is going to be showing you how you can have a AI coding assistant within Visual Studio Code. And the way to do that is going to be using an extension called Continue. An extension Continue allows you to configure what kind of AI you want to use as an assistant, and its ability includes allowing you to chat with the model. You can ask the DeepSeek model or whatever model you want to help you with the task. You can explain what you want. You can attach a file as a context to it. Also, you can get some autocomplete actions from the Continue tool as well. But you need to do some configuration, but I will show you how to do it. But anyway, so you install Visual Studio Code and you install the extension. You install the extension, and then you open this configure.json file and config the file like this. All right, let's do it in concrete. So let me remove what I don't want here, and here it is. Oh, I'll put it right here. All right. Oops. So I am actually going to zoom in. Anyway, first of all, this is my VS Code, and you can find the Continue extension by typing in the Continue over here, and this is it. Make sure that you check for some credibility here, like click this and you get to the website and see if it's legit or not. 600,000 downloads looks okay, but even though it's not like it can be a misleading one, but I think this is great. This is the right one. You install it and you then need to configure it. How to configure it? If you're in a Mac, you press Command-Shift-P and type in continue, open continue config, and you will land a config.json file. What you need to do here is to add this chunk of code to this file for the models. This is for chatting with the model. So you need to provide what models you have access to. In terms of Ollama, this is the context, the syntax that you need to put in. Model, the name of the model in Ollama system. The provider is Ollama, and the title that you will see here. So you can do something crazy like, it doesn't have, what I'm trying to say here is it doesn't have to be exact like this. So you can do something different that you will quickly understand. All right, as an example. For auto completion mode, it's recommended to use the Qwen 2.5 Coder 3B instead of DeepSeek. So make sure you download that model. And in terms of embeddings, if you want to have many files out of context, then it needs to have it needs to process those, right? It's recommended to use the Nomic embedding model instead. All right, so you can configure whatever it is. Here you can learn more about what these things are or the continued abilities in its website. So I'm here just to show you what it can do quickly. What you can actually do here is, let's say that I want to create a code that would do something. You can then type Command I to bring up the interface, right? And then you can type what you want. As an example, I will maybe set up a situation that, let me just back to chat. First, I can select the model I want. If the task is complex, make sure you use a larger model, like for example, the 14 billion parameter ones. So let's say that I want the Python file to do it like this. This is my command, right? Python main.py that when run takes one argument, which is a URL, then use request and beautiful soup to extract information from the given URL, and then return the extracted information as strings if getting URL's info is successful, otherwise return an error as a string. Now I will hit this button and it's going to do its magic. So while it's doing its thing, I want to show you that this guy is being updated. So hopefully that's not going to be so embarrassing, but let's see. Here we go. What model is it trying to load? Here we go. Yeah, it's now trying to load the 14 billion DeepSeek R1 parameter to its system. It's doing some loading and printing out some meta information for us to see, and you can actually check the memories probably that it's using. But anyway, so it's now running, right? Now it's being run, and as you can see here, it has some output. Okay, look at that. Okay, now it tells me to use this. Oh, okay, this is the code main.py. I'm sorry, yeah, that's the main one, blah blah blah. Okay, what I can do here is, if I have it, my cursor there, I can click insert and it will be populated here. All right, well, the moment of truth, let's actually run it. Am I in the right environment? Let's see if I have beautiful soup. Okay, I do. Maybe I should be able to run it. So let's actually get a URL link. Hang on, guys. I am going to use the URL link from the website of the extension itself. So let's try. Poetry run Python demo 3 hi and that. Okay, URL title is correct. This is the title of the web page. Here, meta description, amplified developers, AI enhanced. Yeah, that's the meta description. Are you happy with that? I think so. If you see that this is not the right one, let's try to see that. Awesome. But instead of meta, only meta description, I want all detailed you can get from the URL. Let's see what it's going to do. It's thinking. I actually like the animation that we now can see that it's thinking. Okay. Now it's, again, this is a chain of thought built into the reasoning model, allowing you to see how it's thinking, and you can actually follow through, and at the end you can correct it too. I think this is neat. You know what, like what I observed here is that initially I thought the 14 billion parameter model is going to be slow, but look at that. If I can recall how I felt the GPT-4o respond in terms of speed, I think it's at the same level of GPT-4o API level. And yeah, and this is now running on my laptop with this capability. I think I'm pretty happy with that. All right. I'm a little bit not sure if it will be able to do that. Wow, the code is getting complicated. Hopefully it's going to be finished soon, and then we can try our run. Okay, now it's returning, and now it's okay. This is like a text template, and we're trying to fill in the URL, the title, the meta, and so on. And here we go. Okay, well, explaining the code. All right, let's see if I can actually click this box. Hopefully it's okay. All right, let's actually click apply right here. Oh, okay, now you can selectively accept and reject the line of code here. So I will actually like accept here, accept. Okay. Oh, sorry. Yeah, I should have. Oh, come on. I click accept. Why is it not going through? I have to come to this level. That's weird. All right. So anyway, so it seems like I have accepted all of its recommendation, and therefore I can try to run again. Ooh, that is an error. You know, you can keep going round and round, like here. Got error. Fix it. Analyze and fix it. Yeah, now you have you can have your own AI coding assistant if you have a powerful enough laptop, by the way. I try to use the smaller model like the 1.5 DeepSeek R1 1.5 billion parameter. Really bad at doing code assistant, but for a 14 billion parameter, I think it is okay. You get the performance for free. I think that's worth something. Before I actually continue with my agenda here, and I will leave the DeepSeek R1 trying to fix it, but we are not going to wait for it. Is that I have tried to I've tried asking it to write an HTML code, and my exact request is this: write an HTML code that renders a simple sign-up page, and below here is what it actually came up with. This full disclosure, I do not know how to write HTML code, and if this is the case, then it's actually helping me out a lot, and you can actually see that it's actually not bad, right? Simple sign-up page. Yeah, it can definitely do simple things like this. All right, so for those of you who are not developers, well, your excuses of not doing anything simple is now less and less valid, right? Okay, now next step, this is going to be short. I want to show you that you can also again use DeepSeek in Ollama, and because you have Ollama, you can serve DeepSeek to LangChain. And the application that I want to showcase to you is revisiting my code about YouTube summarization, where we'll take advantage of tools that LangChain has, the load summarization tools, but we will add the DeepSeek R1 model to the model options for using for that capability. So let me actually put the right page here. So if you actually come to my GitHub case done, you can have this repo, you can clone it. So basically what I made it here is a UI interface, and at the back you have Ollama serving in combination with LangChain, and will allows you to, and also some programmatic toolings allowing you to pull in information from a given YouTube video. For example, in the YouTube video tab, you can copy and paste your video of interest in here and get information, and it's going to pull in information like title and description from that video, and then you can get a transcript, and this is going to be the base input towards the summarization method, right? And if you come to the summarization method, you can now select models. By the way, you can improve upon this, because right now I hard code it because, well, I'm going to just use the model that I have. But if you clone my code or fork it, put a star as well if you wish, you can actually change the code, and the line is somewhere it's in the gradual line, almost here, right here. You can change the code. Oh, I need to push the latest information, the latest commit here. But anyway, this is where you provide additional choices to the tool that we'll probably use. Okay, now once you are happy with the transcript here, you can start the summarization. Because the 14 billion parameter is taking a long time to compute, so I took the liberty to actually process it for you with the MapReduce LangChain as default. So make sure that you increase the number of tokens to predict. The reason is that, again, the DeepSeek R1 model is a reasoning model. So before it's actually giving you the input, it will keep projecting out the thinking process, and that's actually consumed the number of tokens. The Ollama will allow the model to predict as well, and therefore, if you don't provide enough of the prediction tokens, you are not going to you are not going to get the final answer, because you might get cut off midway. So yeah, so after it actually think itself through, you will arrive at your answer, the final answer here. Yeah, that's the way it is. Now, let me show you the refined chain. By the way, if you don't know what MapReduce method or refine method is, visit my previous videos where I explain challenges and how to deal with summarization tasks. Summarization tasks will face with a long input text challenge, and those, the MapReduce and the refine methods are proposed to handle that thing. Anyway, so let's try to, you can come here to select the 7 billion parameter model and select that, okay, I'm going to use the refine method, and you just click summarize. And it's going to be running at the back here, and you can see everything in progress, and right now it's at the step to summarize. Now it's, yeah, it's running its thing right now. You can come back to check with the Ollama serve in the terminal too that the model has been loaded right here, right? The 7 billion parameter models is now being served to calculate what we want. Now, I think it's going to take a while because the context length that we provide is pretty large, but it's not too bad. Now, here we go. That's the think, and this is when it has finished thinking, and the summary, the actual answer starts here, right? By the way, the link that when I told you that like you can revisit my previous video, this is exactly the video that I was talking about, where you will learn about the challenges and techniques to solve a summarization problem. All right, that's about using DeepSeek models via Ollama and then plug in, integrated with LangChain. Now, this is the last topic and very exciting one, because Agentic AI is the main theme of 2025 for many research groups as well as companies trying to adopt generative AI to their workflow. And this is thanks to Andrew Ng, who has coined the term Agentic AI. So here we are today, trying to see if DeepSeek model can be, or how can it be used in the Agentic AI development framework. And the framework that I chose to demo today is Small Agents from the Hugging Face team. The reason I picked this is that this agentic framework is small, simple, and if you want to develop a small specific scope application, this is your I think I would love to use this one to get started and prove your concepts, rather than spending hours to actually develop some hardcore agentic framework like LangGraph, for example. Small framework actually allows you to create multi-step agent that actually will keep going into subtasks until the main task is done. That's the multi-step agent, but also allows you to do multi-agent system where multiple agents talk together and work to solve a bigger task given. But I'm not going to talk about the whole framework of small agent framework today. So please stay tuned for an episode dedicated to this topic. Sign up, click subscribe, and you'll get a notification when this episode is ready. But I will actually give you a quick demo of how this is going to be and how DeepSeek model fits into this one. All right, so I have actually prepared 3 versions because I wanted to compare the performance of the small DeepSeek model, the 1.5 billion parameter, to a medium size, 14 billion parameter size. And you can see that you need to pick a large model because agentic framework requires model to think and reason well. And lastly, as a benchmark, because we all know that the GPT-4o mini is capable of function calling and reasoning enough to for me, it's enough to do some simple agentic framework. All right, so let's actually get you to see the good performance of a good model, the GPT-4o. All right, so let me actually restart the session here. This is importing stuff, and you don't need to focus a lot here, but again, the agent is going to be created by the code agent. Code agent is a way that the Hugging Face team design its agent to be. The agent wouldn't understand tasks and can write code and execute the code, and that's the essence of it. So let me just load that up, and this is going to initialize the model instance talking to API over to OpenAI server, and we call the GPT-4o mini for use here. Now we actually create an agent with the code agent, provide the model that we want to use, and you equip the agent with the Python interpreter tool. And that's pretty much it. And we will allow the agent to do the task at maximum only 3 steps. So the task that I'll show you today here is to calculate a math. And this is what's the log of 10 to the exponential of 20? If you know math, the answer is 20, right away. But in agentic framework, we know that LLM itself can hallucinate, especially when it needs to deal with math calculation. So the agentic framework promises you that the agent will know to call a calculator tool to solve a math problem. All right, so the correct way for the model to do this task is to actually call the Python interpreter tool and code so that it can solve this expression. All right, this is the query. Now I am going to send the query to the agent, and the agent has a brain of the GPT-4o mini. Okay, now we see that, oh, step 1, I need to write this code, but look at that, it uses its own knowledge. Maybe this question is too easy for it, and the answer is correct. So this is not illustrating my point, so let me just tweak the number a little bit to make it a little bit harder. Now when it's not as simple, it should be actually triggering the tool. Right, now it's actually trying to write code to solve that particular problem, because the solution, the question requires you to actually use a calculator now, and the answer is 6.2. I think this is right. You know what? Maybe I will embarrass myself. Let me just do that over here. But let me just import that and math log 10 of 20. That's what I want, right? Ooh, am I going to embarrass myself here? Oops. Oh, come on. Okay. Is it a log? Am I doing the right thing? Okay. Okay, now the answer that it gives me is 6.2, 6.02. Am I doing something wrong here? A log of 2 to the 20. See, I am embarrassing myself. Oh my god, this is interesting challenge. Okay, you know what? Let me cheat a little bit. Instead of 4O mini, let me use 4O. Instead, the query is still the same. Log 2 to the 20. And let me run this. Oh wait, hold on. Why is it still 4O mini? Oh, my bad. I need to reinitialize agent. Okay, something is strange. Let me just interrupt. Okay, let me try it again. 4O and create my agent. And this is the same query. And run. Maybe this is overflowing. Okay, let me just reduce the number. Let's do 2. Maybe 2 to the 2 is too much. Yeah, I think it's too big. So the math ground truth is, oh, come on. What is happening? Domain error. Oh, my bad. See, I'm embarrassing myself. Okay, we need to be able to get to like 6.02. Log of 2 to the power of 2, okay? And the model gives me answer of 0.602, which is the right one here. Okay, so I actually figure out that 2 to the power 20 is probably too big for the float system that we have. Now, you can see that the model write the code well and execute the number for us, and that's the response, right? When you actually print the response is that. All right, so this is the power of GPT-4o, and if we actually go back to the mini, I think it should have the same answer. Okay, we are now running the same math problem with GPT-4o mini. Log of 2 to the power of 2, which is log of 4, right? Now it actually does some, I don't know why it needs to do some logic here, but the answer is still 0.602, according to what we see before. All right, now we know that, okay, this is the performance of the GPT-4o and 4o mini. Now let's actually experiment or try with the DeepSeek R1 14 billion parameter on my local computer. So let me refresh the kernel. Now import my stuff, initialize a model. Now you notice that this is the 14 billion parameter of DeepSeek R1 model. Then we'll give it the same query. Now we hit the agent, right? The agent now is thinking. Now it has, just to remind you, DeepSeek R1 has a thinking ability, and it will think its way through to the final answer. Now I think this is thinking was taking quite long to finish. Step 1 is taking so long. So while we are waiting for that, let me actually just update this to be the same as previous other models. Now it's actually quite long, so let me actually check if it's running. Right, it's running. The reason can be that there are many rounds of models communicating. One thing about agentic workflow is that it usually takes a lot of tokens, and that's because there is an underlying orchestration layer, a lot of prompting in there. Therefore, you are likely to consume a lot of tokens compared to just a single pass LLM. Now with the 14 billion parameter, and you can see that it made some error, and this error is likely to be because the way it's actually working its way through is not in the right syntax for the output parser to do it correctly. As you can see here, the error is happening because inside the code parsing, right? And that's actually related to the orchestration layer, because there is going to be a protocol of the parser of one agent output to the other. Is actually taking quite long. Now step 1, it has failed. Step 1, it has failed because it has encountered an error. Now it entered the stage number 2, where it's trying to compute again with this code, and somehow this is right, and it has the answer 0.602 as we have before. Yep, that's pretty much the capability of the 14 billion parameter. Well, you have to give it some credit. It's a small model, and the fact that it can actually arrive at this point after 3 steps, it's good. By the way, you're running this model locally, so yeah, it's not too bad. So let's actually try the smallest one, the 1.5 billion parameter. Actually, I want to interrupt the model here because it's taking too long now. Okay, now we are back to the 1.5 billion parameter, and I think what we'll see here is that it's going to make a lot of errors. Now I created an agent instance with the 1.5 billion parameter DeepSeek model. The step number 1, it just gave me a code without any import or anything. That's why it ran into can't import a function. Yeah, interpreter error, not permitted to evaluate other functions with the provided tools. It also ran into the problem again. This is syntax related, and parsing error. So all of the 3 steps that it has a chance to fix or solve the problem, it failed, and eventually you are not going to get any response. You are just going to get the way it thinks, right? The reason is that the model is too small to have a good reasoning ability to solve this task. The agentic task is quite difficult. And one thing that I want you to take a look here is that all the mistakes that it has done before, it's inserted it as a context, and that's why you are consuming more and more input tokens as the agent struggles to finish the task. And that's one of the costs that a lot of agentic system is getting expensive, because when error happens, everything is used as a context for the agent trying to solve itself. All right, that's pretty much it for the Agentic AI powered by the small agent framework and with the DeepSeek model. And that is all for today. We have gone through a lot of topics, even though it's not a big change or big topic. I think it will provide you with a lot of values because you can now have models with high reasoning abilities running on your local machine or even your own laptop, and we go through how DeepSeek model is created and also how you can use it with Ollama, then Open WebUI, Visual Studio Code as an AI assisting you in coding work. And also now you know that it's possible to use at least the 14 billion parameter model as an agentic brain inside an agentic framework like a small framework. And this is it for episode 20. Before you actually go, don't forget to subscribe to our channel. We are Keston. We are on YouTube, LinkedIn, Facebook, X, and Substack. And for now, thank you very much and have a good day. See you next time.